Welcome to Maths with El Profe Lo. I'm going to be doing some elementary number theory. James K. Strayer is the author of this text, looking at 1.3, the greatest common divisors. We've got this definition from our text. It says if A and B are integers, where A and B are not both 0, then the greatest common divisor of A and B, denoted by these parentheses, A comma B, right, that this is the greatest positive integer D such that D divides A and D divides B. If that greatest common divisor is equal to 1, then A and B are said to be relatively prime. The terms coprime and mutually prime are synonymous with relatively prime. So depending on where you're going to school, what you're looking at may be that you sometimes see the words coprime rather than relatively prime, or sometimes see the words mutually prime. Okay? So a short example, and we could say, well, what are the divisors of 35, right? Well, a way to find the divisors of 35 is just to know your multiplication tables. Say, hey, we know that 1 times 35, 4, 5 times 7, but I could have positive or negative for those divisors, because I could have -1 times -35, -5 times 7, or the positives of those, right? And if we consider the divisors of 24, same thing for our multiplication tables. We can go through and say, hey, 1, 2, 3, 4, 6, 8, 12, 24, because 1 times 24, 2 times 12, 3 times 8, 4 times 6. So these are the divisors. And we're looking for what is the greatest common divisor, right? Well, if we look here, we have 5, 7, and 35 as the divisors of 35, but none of those are divisors of 24. So the greatest one that they have in common is 1, right? So that greatest common divisor of 24 and 35 is 1. Which is denoted by this, where you have the parentheses with the 24 and the 35 is equal to 1. Since 24, comma 35 is equal to 1, right? So since that greatest common divisor is 1, then 24 and 35 are said to be relatively prime. Okay. Now, it's important to note, all right, that in definition 9, we're talking about the greatest positive integer D. Right? So because D is a positive integer from definition 9, it is common practice to only consider the positive divisors of A and B when finding that greatest common divisor. Okay? So we're going to do a few examples here, and it says find the greatest common divisors below. I would suggest using technology, a website such as Wolfram Alpha, or similar, to obtain the divisors. How does that work? Well, we can come over here and we can say, hey, what are my divisors of 35, right? We already did that one, and it'll pull up the information. We see 1, 5, 7, and 35, right? And we can say, okay, well, I know, right, just kind of, we'll write that information down. We know that for 35, I have those divisors, 1, 5, 7, and 35. And what about for 56? Well, I can come back here. What are my divisors of 56? All right. And the time that it takes to pull that information up, for some people, they might be able to find that information a little bit more rapidly than others. Okay. And so we see those divisors are 1, 2, 4, 7, 8, 14, 28, and 56, okay? So what does that tell us? That tells us that the greatest common divisor of the two is going to be the greatest number that's in common with both of them. And it appears to be, when we look at this, 7, right? So we would say that the greatest common divisor is 7, okay? What about for the next one, right? Pause the video, try it out, unpause the video, and see how your result comes out. So, did you find the divisors of 32 and the divisors of 49? Right? The divisors of 32, 1, 2, 4, 8, 16, 32. The divisors of 49, 1, 7, and 49. All right, once again, you could use Wolfram Alpha to double check that. We see those divisors, okay? And so because the greatest common divisor is 1, we would say that the greatest common divisor of 32 and 49 is 1, and therefore we are relatively prime. Okay. Now, let's talk about the notation for this next one. All right, we have 24, 32, 56. We have 3 of them in here, right? How do you think you would approach that? Well, you would consider the divisors for each, the divisors of 24, the divisors of 32, the divisors of 56, and see what is the greatest one for the 3 of them. All right, so pause the video, give that a little try, and then unpause the video and check it out. We said to pause the video, right? Try it on your own before you see. So, did you notice that each of these, 24, 32, and 56, the divisors we had already listed out, right? The divisors 24, you could have just referred back to your list already. The divisors of 32, the divisors of 56, right? We had each of those already there, but of course you could have come and used Wolfram Alpha to find, right? Divisors of 56 and get the information that you were looking for. And we want the greatest one that's in common between all of these, right? So if we scan, we see everything has 1, we see everything has 2, right? We see those that have the 4, and it appears that the greatest common divisor, it appears the greatest common divisor there is going to be 8. And so we would simply write the 24, 32, 56 is going to be equal to 8. So it is possible to find the greatest common divisor of more than just a pair of integers. We could do it for a larger number of integers, and that's going to be the notation. Okay? If you have questions, please reach out. But if you're still here, let's show you a little trick that you can use with Wolfram Alpha to check your work. We can put in here, right, GCD of 24, 32, and 56. Here's my input. The result is 8, which matches what we have, okay? Note that that is a nice way to check your work, but if you're going to show your work, this is the information that needs to be evident. We need to see each of those sets of divisors and clearly indicate that you are identifying what you need to have, okay? So now, for real, have a great one. Maths with el Profe Lo.